Well, good afternoon, class. Today we're looking at piecewise and quadratic functions. We're going to look at piecewise functions first.
We defined functions the last time, so we're continuing that discussion.
Y'all remember we said that a function for every x value, there can be only one y value. So keep that in mind. For every x, there's one and only one y. And with a piecewise function, is a function that's defined using more than one algebraic piece or algebraic expression. It uses two or more algebraic expressions to determine the y value. And there's really no way to talk about a piecewise function without looking at an example. We're going to do two things with piecewise functions today. We're going to evaluate them, and then we're going to graph them. Evaluating is very fast. We're going to...
Let's do number two.
We're going to, first of all, evaluate.
Oh, what are you evaluating?
Evaluate piecewise functions.
Back in the olden days, you learned little poems to help with spelling. I before E except after C, or when it sounded like A as in neighbor and way.
Either, neither, forfeit, seizure, or weird.
Did y'all study that in school now? That was back in the olden
days.
Okay, so let's do problem number
two.
Really good one.
We're teaching about things that were back in the olden days.
I know.
Okay, so this is an example. What we're seeing here, this h of x, is an example of a piecewise function. There are three different pieces that you use, and they want us to evaluate the function at -10, at +2, at +4, and at +6. I need to write down this function. Let me do that.
And maybe write each piece in a different color.
That's exactly what I'm going to do, Tony. So we have h of x equals, there are three pieces. -3x minus 11 will be used to determine the y value for x values that are less than -8. We're going to use the piece, this is nice, it's constant, it's just a 4. The y value will be 4 for x values between -8 and +4.
Did y'all notice how he said, instead of saying for -8 less than or equal to x less than 4, if you see 2 less than,
oh, it's just a less than. Oh my goodness, I miscopied. Okay, they can't see it, but it's just a less than. Okay.
But if you see 2 less than or 2 greater thans in the same statement, read it as between. Start with the middle for x's between -8 and 4.
Okay, let's switch it. Well, I better make sure I don't miscopy anything else, because a little miscopy will certainly throw off our answers. Okay. And let's switch to my paper. Here's the function. Oh, I forgot what they wanted.
H of -10 is the
first. So they want h of -10. Switch back. I'm going to write them all down, the ones they're looking for. H of -10. There's 4 of them that they want us to evaluate.
H of 2, 4, 6.
2, 4, and 6. Okay. We saw the last time that the number in the parentheses is what you plug in for x. That number there is the x. The value of the function is the y value. The question is, which one of these pieces are we going to have to use? To make that decision, you have to look at the number that's in the parentheses, x. Negative 10 is our x value. Which inequality is satisfied by the x value negative 10? Is negative 10 less than negative 8? Or is negative 10 between negative 8 and positive 4? Or is negative 10 bigger than positive 4? Which one inequality is satisfied? The green, red, or blue? The green one. Negative 10 is less than negative 8. So we're going to use the green piece. Plug in your negative 10. That's negative 3 times negative 10 minus 11. Negative 3 times negative 10, well, we know that's 30, minus 11, we get the y value of 19. Any questions there? You can't decide you're going to plug it in down here. If you plugged in negative 10 down here in this blue piece, negative 10 plus 2, that's a negative 8. Remember, for a function, you can only get one correct y value for each individual x value. The correct y value for negative 10 is positive 19. But you're just plugging in the x value basically, but you have to decide which piece you're using. Okay, for this one, our x value is 2. Is 2 less than negative 8? Or is 2 between negative 8 and positive 4? Or is 2 bigger than 4? Green, red, or blue? Which piece? The green one.
No, the red one.
I mean the red one. The red one. The red one. 2 is between negative 8 and positive 4. 2 is between there. We go to the red piece. Oh, this is nice. There's not a variable to plug into. The y value is just 4. Any questions on my logic there?
Constant.
It is, this middle piece is a constant piece. Now, the third piece, third value, h of 4. h of 4, our x value is 4. Be careful. Which one will we use to find h of 4? It's hard to tell what I have written there. Flip back to the original problem. When I was writing it down, I put an equal sign there. But notice, there's no equality there on 4. The equality should be on the third piece. Do y'all see that? That's where x can equal 4. So make sure you can read what I've written here. I marked out that equality bar right there. Okay, x is 4. Which one of these pieces allows x to equal 4? The blue one. Notice there's the equality. So we're using the blue piece. You plug in 4 for x. You get 4 plus 2. So the y value is 6. And I should have boxed in that previous answer also. Any questions on my logic? Okay, I'm not going to say anything. For h of 6, which piece do we use? Green, red, or blue? The blue piece, 6 is bigger than 4. Before you can decide which piece you're plugging into, you have to look at the inequalities and compare the x value they give you. 6 is bigger than 4, so you're using the blue piece. 6 plus 2, which is 8.
I had 2 more.
I am.
H of 0, H of 100, H of negative 100.
Okay. H of 0, H of 100, and H of negative 100. You know something? Maybe you should type in the correct answers right now, though, before we get timed out.
Oh.
I just want to make a few more examples.
forgot what they were.
19, 4, 6, and 8.
4, 6,
and 8.
8. Mm-hmm. 2, 8, 9.
But notice the way they had the X values in the order of which these things were listed. So let's suppose that the X values aren't necessarily in the order in which they're listed. H of 0, which piece would I use? Green, red, or blue? Is 0 less than -8?
Now remember, less than -8 means like to the left of -8. -9, -10, -11, and so forth.
Or is 0 between -8 and +4? Or is 0 bigger than 4? Which one, green, red, or blue? Red again, so the Y value is just that constant 4. Nothing to plug in, it's just a constant 4. What about H of 100? The X value is 100. Which piece will we use? Green, red, or blue? We're going to use the blue one. The X value is bigger than 100. 100 is bigger than 4. So we're plugging into the blue one. 100 plus 2 gives me a Y value of 102.
I remember once a student asking me, well, wait, how would we do this if it didn't have all of this stuff here?
It has to have that.
I was like, it has to. It can't just be the rules without what they're used for.
And finally, H of -100. H of -100. Our X value is -100. Which inequality is satisfied by the X value of -100? The green one, so that's a -3. Plugging in the -100. That becomes 300 minus 11, which is 289.
So is it clear? You've got to decide based on the X value which one you plug in by looking over here first.
So, any questions before we go on? We're doing two things with piecewise functions today. We're evaluating and we're graphing. The evaluation is pretty fast. The graphing, well, it's a little more involved. So I'm going to write graphing piecewise functions.
So imagine if you were graphing something similar to it. On the bright side, the graphing is multiple choice. You can graph piecewise functions. By the time this is over, you know a lot about graphing, or you understand a lot about graphing.
This is number 6. We'll go back to early ones in a moment, but I like this one. Not a f of x equals, it's a 3-parter. We'll graph the part. We'll use 4 plus 2x to determine the y values if x is less than -4. We'll use the piece y equals -2x if x is between -4 and +5. And we'll use the piece y equals 2x at +2x if x is greater than 5.
Last time, can you do plus 2x? What?
I don't know. What do you think?
I thought it looked good.
I think I can do it down here. I'll make the table small, I think.
Okay.
Yeah, let me make sure that miscopy. If I miscopy, that's going to throw off everything. Negative 2x and 2x. Yes, that's it. Okay.
So hopefully you at least in your mind know I'm going to have a graph that has, that's a brown piece. There's going to be a piece of the graph that's brown, a piece of the graph that's green, and a piece of the graph that's red, and it's going to pass that vertical line test. Remember, a vertical line cannot intersect a
function in 2 or more spots. So what we're going to do to graph these things is plot points. But we're going to plot points intelligently. We're not just going to start randomly choosing x values to plug in. Now, when I look at these pieces, y equals 4 plus 2x. That's like y equals 2x plus 4, y equals mx plus b. Y equals negative 2x, y equals positive 2x. What do we expect those graphs to look like?
There's no exponent.
I don't see any fractions, I don't see any exponents. Y equals mx plus b. What will that graph be?
Starts with an L. Linear, a line?
A line. So we're going to have 3 lines. What's the minimum number of points you need to draw a line? The minimum number of points, ordered pairs, 2. That's what we're going to do. We're going to get 2 distinct points, but we're not just going to randomly choose our x values to plug in. Here's the procedure. The first thing, okay, I'm using different colors. It's hard to tell. That's a blue there. I mean, that's a brown there. Maybe I should have used blue.
But Tim,
it doesn't matter. So I'm going to number each part so you can tell which table goes to which piece. That piece there will be piece number 1. There's piece 2. And here's piece 3. I'm going to start with piece 1. I'm going to make a table of values.
These numbers over here on the right, where the constraints, if you will, these numbers are -4 and +5. We call those cut points because they're going to be sort of like the cut points with the cut point method. Right?
For lack of anything, a better word, I suppose cut points is the best that we can use. The brown part cuts off at -4 and it switches to the green part. At +5, the green part stops and it switches to the red part. So I think cut points are good names to call those numbers, and we're going to use the rules for labeling the cut points that we use for labeling solution cut points when solving a nonlinear inequality. The first number that you must plug in for your table is any cut point that appears within the inequality. I see a -4 here in this brown inequality. I have to plug in that -4. But look a moment. Is equality allowed here? With the first piece, can x actually equal -4? No. So to indicate that we're plugging in a cut point that doesn't allow equality, we're going to label this. Once we start drawing, this ordered pair is going to be labeled with an open circle. Y'all said we need 2 ordered pairs to uniquely draw a line, so we need another x value. Well, there's only one cut point on the brown piece, so we need another cut point, one that satisfies the inequality, an x value that's less than -4. Well, what do y'all want to use? You get to choose one. You could say, well, we'll use -10. But be careful. You're going to have to be counting out the -10 units. And if you use -10, you're going to wind up with what? -16y. My advice to you, choose a number close to that cut point. What's immediately to the left of -4? What integer is to the left of -4 on the number line? -5. Now, any number that you choose on your own, the numbers you choose on your own have to satisfy the inequality. So they're going to be, when you label it, it's just a regular closed dot.
Only time you'll have open circles are at the cut points that don't have an equal sign.
Okay, let's plug in -4. We're plugging it into the orange piece. 4 plus 2 times -4. Here's my scratch work right here. We're plugging -4, not the blue piece, the brown piece. 4 plus 2 times -4. That's a 4 plus a -8. What am I getting for this y value here? Yeah, it's just a coincidence, the same as the x value. That is just a coincidence. Now plug in -5. We're not going to get a -5, okay? Plug in -5. What are we going to get? We have 4 plus 2 times -5. That's a 4 minus 10. What are we getting for y here? -6. I agree. I'm going to go ahead and draw my XY grid. And
put it up high.
I think I go right here.
Yeah, little marks there, I bet you.
Okay, we're just freehanding the grid.
Let's see all those marks.
So let's see. Be sure to clearly label. Be sure to clearly label the cut points on your x-axis. You clearly have to label out. -4. 1, 2, 3. Oh goodness, you're right. This is I'm going to need a -10 in a moment. Maybe we better, let's just make the tables first, okay? Let's just make the tables. Let's make all of the tables. I may have to go to a whole new piece of paper to draw the graph.
Yeah. You didn't get lucky with the numbers. Here, it's giving you big y values.
The second, we need 2 ordered pairs to graph this green piece. We don't have any choice in the numbers that we use to plug in. Any numbers that appear within the inequalities have to be plugged in. So we're going to have to plug in a -4. We're going to have to plug in the +5. Notice those cut points are labeled with equality, so we're not going to have an open circle there. We'll have closed circles at both of those points. Plugging the -4 into the green piece, -2 times -4, what are we going to get for the y value? Plugging -4 into the green piece.
8.
Okay. Plugging 5 into the green piece, -2 times 5, what are we going to get for the y value when we plug in 5? -10. I agree. Third and final piece, the red piece. I have to plug in 5. Any number, and we'll discuss why we plug it. You say, well, x can't equal 5, so why are we plugging in 5? We'll discuss that once we're through drawing the graph. There's an algebraic reason why we have to plug in that 5. We have to plug in the 5, but there's no equality, so open circle. Now we need another x value, one that's actually bigger than 5. What do y'all want to use? 6. 6 is a good option. Is this going to be an open circle? It's going to be a regular closed dot.
Because only cut points can have open circles, and only the ones that have no equal.
Notice when we plug in 5 here, 5 is not greater than 5. So that's why it's open. But the number you choose, 6, that does satisfy the inequality. An open circle means you're plugging in a number that doesn't satisfy the inequality. Any other number you plug in has to satisfy it, so it's a regular closed dot. Plugging in 5 into the red piece, what are we going to get? 2 times 5 is 10. Plugging 6 into the red piece, what are we going to get? 12. And then I'm going to turn the page, and I'm making a big, because notice, we're going to have to go up 12. We're going to have to go down 10.
If you want to use this, and that way you can have both of them on there. Yeah, you're going to have at least 10 marks on the white, positive 10 and negative 10.
Let's see. The biggest y value we get is 12, and the smallest y value we got was what? Negative 10. 1, 2, 3. There's 12. Negative 10. And the
Negative 4.
negative 4 and positive 5. Negative 4 and positive 5. The first one we're going to plot, the brown piece. We have an open circle at negative 4, negative 4. And then the secondary point is at negative 5, negative 6. So we have an open circle at negative 4, negative 4, right there. Okay. There. So we have an open circle at negative 4, negative 4. We have a regular closed dot at negative 5, negative 6. That's negative 4. So there's negative 5. We go down right there. The interval the graph starts at the cut point. It goes towards that secondary point you found. It's starting at negative 4 and going to the left. Does that interval ever stop? X less than negative 4. Will this interval on the x-axis ever stop? No. So the left side of the graph can never stop. It's going to keep going and going. I'll put an arrowhead there. Now it doesn't continue to go past the cut point. It doesn't continue to go past the cut point because these numbers out here are not less than negative 4.
So between.
Now, the next interval. The green interval, notice it runs between negative 4 and positive 5. We have closed dots. At negative 4, we go up 8. Let's see. I guess 1, 2, 3, 4, 5, 6, 7, 8. So at negative 4, we're up 8 units. We have a closed dot. At positive 5, we're down 10 units. Right there. At positive 5, we're down 10 units. We have another closed dot. This is the ordered pair -4, 8. That was the first point we got for the green piece. This is the point 5, -10. That's the second point. So we're going to start and connect the dots there. And here's my question. Do we have any arrowheads? And if so, on which side? Left or right?
Or neither. In
Does
words,
this interval, does the interval from -4 to +5 continue going forever and ever in any direction? No, it has a definite starting and stopping point. That green piece starts at -4, 8 and ends at 5, -10. It is just a line segment. That middle part has the line segment. It's just a line segment.
in words, the brown graph starts at -4 and moves to the left. The green graph is strictly between -4 and 5. There can't be any arrows on it. The red graph
It starts
starts
at
at 5 and goes. Well,
Okay, there's 5. Right 5 up 10. Right 5 up 10. And then the second point, right 6 up 12. The graph starts at the cut point, 5, 10, and it goes to the right. Does it stop? Does this third piece stop? Is it like this thing here, where it starts and stops? Or does it keep going forever?
Numbers bigger than 5.
X bigger than 5. On the x-axis, the numbers that are bigger than 5, does that interval ever stop? No, so it keeps going to the right, so the right side of the graph has to keep going. If you're going to have arrowheads on these piecewise functions, you can only have,
Oh, you should have. Yeah.
if you're going to have arrowheads, you can only have one arrowhead on the left, one arrowhead on the rightmost portion of the graph. You can't have arrowheads appearing throughout. And notice,
Because
this thing passes the vertical line test. You try to draw a vertical line, there's no time it's going to hit the green part and that brown part. You say, well, what about here and here at 5? No, this thing isn't shaded in here.
It's not a point.
It's not a point. So the vertical line test, this graph does pass the vertical line test. Any questions there? Now we have to choose, it's a multiple choice problem. We have to choose the graph that looks the closest to this one here.
And then you're going to tell why you.
But then, and once we're through, I'll then discuss why are we plugging in these cut points that do not allow equality. And try making those, let's see. We're just going to pop them out. Hey, that might be it. What do y'all think? They're incrementing in units of 2. I guess that's what I should have done rather than incrementing in units of 1. I think that's it.
But I look at it, are the shapes the same, and do they have right, close, close, right? I mean, open, close, close, open. I think it's A, but let's knock out the rest of it.
Clearly not B. Clearly not C. And D, clearly not D. Response A. We're just plotting points, but we're plotting the points intelligently. We're not just randomly choosing X values to plug in. You have to plug in the cut point. Then you plug in an X value that satisfies that inequality. If it's a compound inequality, you have to plug in both of the cut points, and there are no arrowheads on that piece, There's a definite starting and stopping. Now, why are we plugging in like -4 and +5? Why did we plug in a 5 here for this red piece when it says only use the red piece if x is greater than 5? Well, 5 isn't greater than 5. Why did we do that? I claim that the real number system is it's what we call dense. Between any two real numbers, there are infinitely many more real numbers. There are infinitely many numbers between 5 and 6. Think about that. You could say, okay, 5.1 or 5.01 or 5.001, 5.0001. You can just keep on sticking on zeros. Suppose we wanted to plug in 5.0001. Does that satisfy this condition? Yes. 2 times 5.0001 is a 10.0002. And this point, since that 5.0001 is bigger than 5, it has to be a closed dot. Well, if I wanted you to label this point 5.0001, 10.0002. I want you to label, show me where that point is located on an XY grid. If you were going to label this point, if you were going to label this ordered pair, to the naked eye, what would it look like you're labeling? You'd go 5 and barely over. You'd go 10 and barely up. What does it look like I'm pointing at to the naked eye? What ordered pair does it look like I have here? 510, that's why we have to plot 510. 510 is not on the graph, but there are plenty of points that look like 510 that are on the graph. That's why you have to plug in that 5 to take care of all these points, ordered pairs that look like 510 that are on the graph. But 510 itself is not on the red piece. Does that answer why we have to plug? Same thing here. If you plugged in -4.000001, you would get a -4.00002. Would that be it? But either way, it would look like the ordered pair -4, -4. That's why you have to plug in the cut points even if there's no equality. But how do you indicate you're plugging in a cut point that doesn't have equality? You label it with an open circle. Any questions there? We need to see another one. Number 5. We're backing up. Go into number 5. Oh, look at this. I'm messing up my paper.
Number 6 is the only one that has 3 pieces. The other ones have 2. So if you can understand number 6, you know how to graph a piecewise function.
F of x equals, okay, this is a 2-parter. Oh, I like this. The y value is -3 if you use an x values less than or equal to 2, and it's -2 if the x value you're using is greater than 2. There are 2 pieces here, so we're going to make 2 tables of values, table 1 and table 2. Table 1. I don't have any choice. What's the first number I must use for x in table 1? Oh, wait a minute. You're right. You haven't switched it, have you? There it is. There. I guess I should have looked and made sure I didn't miscopy it. Is that what was written? Is this what we had written? I mean, the function? Okay. We don't have a choice. What's the first number we must use for x here in this green piece? 2. Now it's a cut point. Is that cut point going to be open? It's going to be a regular closed dot because there is equality. So we'll have a closed dot where we plug in that 2. Now we need another x value, one that's less than 2. What's my favorite number to use? What's my favorite number to plug in? 0. Is 0 less than 2? Yeah, let's use 0 then. Now, is this going to be an open dot? Any number that you choose on your own that's not a cut point must automatically be a regular closed dot. You can only have an open dot when you're plugging in a cut point for which there's no equality. Oh, these y values are nice. For 0 and 2, what will I have as the y value? For the green piece, what will the y value be? There's no x to plug in, -3. I agree. Let's make the second table, then we'll draw the graph. What's the first number I have to plug in for x for the red piece? I have to use that cut point 2, but since there's no equality, I'm going to have to label this cut point with
Open or close?
open circle. Now I need an x value bigger than 2. What do you want to use? 3? I could use 50,000, but I don't want to count out 50,000 units. I could use any number bigger than 2, but use something that's easy to label. In both cases, what will the y values be? -2. There's no variable to plug in. Oh, I forgot to ask y'all. The secondary point here that we chose, 3, -2, is that going to be an open circle also? No. The only time you have an open circle is when you're plugging in a cut point for which there's no equality. 3 isn't a cut point. You chose 3 because it made this inequality true. 3 is greater than 2. So any secondary points you choose are just plain closed dots.
When you do more and more of these, you can look and say, oh, well, on this one, there's just going to be one red open circle. Right? There's no green open circles. It's one red open circle. Now, wouldn't it have been nice if the first one had had such nice numbers?
Yeah, I'm trying not to complain about that, okay? Because then those people that were complaining at that conference that time that couldn't really complain because they couldn't control the numbers, you know.
I know, but I mean, really, you know.
Okay, the only cut point is 2. The green piece changes at the red piece at 2.
Let me interrupt for a moment. Let me see if y'all can answer this question. The green graph is going to be where? To the left of 2 or to the right of 2? Where's the green graph going to be?
Will it be out here or will it be out there? A or B? Where will the green graph be? Where will I have green ink? Is it going to be on this side of the graph or on this side?
I want to say the right side.
Where is the x-axis less than 2? I think it's out here, isn't it? The x-axis less than 2? I'm doing a bad job of asking this question.
I should have kept my mouth shut.
Yeah, you should have.
But look, what I wanted to point out was the little arrow, the way it's pointing. Okay, it's pointing to the left of 2, and the red graph is going to be pointing to the right
of 2.
I had a student once ask me, is that right? Will it always point? Yeah, it's pointing that way to the right of 2. Here it's pointing to the left, so it's to the left of 2.
So at 2, -3, we have a regular closed dot. And then 0, -3, that's right here on the y-axis. It starts at the cut point, it goes to the left. Does it keep going or does it stop? Does this interval x less than 2, does it ever stop? The x-axis, no, it never stops, so the left side of the graph never stops going. What about the right side? 2, negative 3.
No, 2, negative 2.
I mean 2, negative 2. Right 2, down 2, we have an open circle. Then we go right 3, down 2. That's a regular closed dot. Is that it, or does the graph keep going? It keeps going. The interval x greater than 2 keeps going to the right. So the rightmost portion of the graph has an arrowhead. The leftmost portion of the graph has an arrowhead. You cannot have arrowheads in the middle. If you had arrowheads going on and on here, that graph wouldn't pass the vertical line test. In order to be a function, there can only be at most 2 arrowheads, one on the right, one on the left. Any questions there?
Come over here. Let's look at the answer choices. Okay.
A, let's see.
Is it A, yes or no?
Be careful, for a second I thought it was, but look at the open and closed circles. I think they've reversed the open and closed circles, haven't they?
Mm-hmm.
So it's not that one. B, what do y'all think? Is that it? I think it is.
Mm-hmm. Each unit is 1. 1, 2, 3. 1, 2. I'm thinking it's B, but just knock out C and D.
Clearly not C. And clearly not D.
So
y'all agree with response B?
Okay.
Any questions there? Number 3. Put this frame. Okay, I'll do it. So this, just to write the problem down.
Okay.
Here's number 3. We're still graphing. Just says to draw the graph. Let me write the problem down. We use the part x minus 1 if our x value is less than or equal to negative 3. Oh, why did I do that? I did the print. Well, okay, that's okay because then I'll use green. We'll use negative 4 if my x value is bigger than negative 3. Let me make sure that here, x is less than or equal to negative 3, greater than, okay. How many tables of values will I need to make here? 2, because there are 2 pieces. What's the cut point? Where is that brown piece going to change to the green piece? At what number on the x-axis? Negative 3 is the cut point. You're going to have to use negative 3 for your x-coordinate, your first x-coordinate, and I'm numbering these pieces, table 1, table 2. Do y'all see why I'm numbering them? So you can tell this table here, number 1, goes to that first piece. The first number I must plug in for x is, I have to use that cut point negative 3. Will it be open or will it be closed?
Closed.
Closed because there's equality. Now I need another x value, x less than negative 3. Can I use 0? Be careful. Is 0 smaller than negative 3? You got to use a number. Here's your x axis. You have to use a number to the left of negative 3. 1, 2. There's negative 3. We need a number to the left of negative 3. We need a number to the left of negative 3. So can we use 0? No, not for the brown piece. What do y'all want to use? I couldn't hear you. Negative 4, okay. Plug in negative 4 into the brown piece. What are we going to get? negative 3 minus 1 gives me a, we have negative 3 minus 1, that, a negative 4, okay. Plugging negative 4 into the brown piece, negative 4 minus 1, what's that going to give us? Negative 5. Okay, let me make sure. Okay, so left 3 down 4 right there. That's a closed dot. Then left 4 down, that's negative 4, there's negative 5. So left 4 down 5, and that secondary point, I didn't say this, but the secondary point, the number you choose on your own, it has to satisfy the inequality, so those secondary points are always just plain closed dots. So I start at the cut point and I go to the left. Do I stop or do I keep going? The interval x less than negative 3. I started at the cut point, I'm going to the left. Will that interval stop or does it keep going? It's going to keep on going. The x-axis less than negative 3 never stops, so the left side of the graph can never stop. Here's something you might want to remember. You can never have an arrowhead passing through a cut point. A cut point is a starting or a stopping point. You can't have an arrowhead on the side of a cut point. Now the green piece. Table 2. What's the first number I must use for x in the green piece? I have to use negative 3 even though there's no equality. I have to use negative 3. There's no equality, so I expect this cut point to be an open circle. Now I need another x value, an x value that's bigger than negative 3. A number to the right of negative 3. What do y'all think I'll use? 0? Yeah, I think I'll use 0. So I'll use 0. Now, is this secondary point going to be an open circle also? It's going to be a regular closed dot. You can only have an open circle if you're plugging in a cut point for which there's no equality. Well, if x is negative 3 on the green piece, what's y?
Negative.
0. Using 0 for x, what's y? I go to negative 3, negative 4, fully expecting to put an open circle. When I go there, what do I discover is sitting there? I go to negative 3, negative 4, intending to put an open circle, but what have I already got there? If you have an open and a closed circle appearing at the same spot, the closed circle takes precedence. So we have a closed circle, it stays a closed circle. Then 0, negative 4. So we're starting at this cut point. We're going to the right. Is it going to stop? Will the x-axis greater than negative 3? That's to the right. Is it ever going to stop? No. So the graph keeps on going. Now,
Brown and green look alike.
I know it. They do. My goodness.
They look the same up there. They all look black.
Well, let's make sure, to y'all, does it look the same on the projector, the green and brown, or is it our bad vision?
It looks the same.
It's the same. Well, so let's go back to the important thing about this problem. If you have an open and a closed dot appearing at the same cut point, the closed dot takes precedence. An open circle says, hey, this ordered pair isn't on the graph. But yes, it is. It's on the graph because of the other piece. That's why if you have an open and closed appearing at the same time, your graph, the open circle says this ordered pair is not on the graph. The closed circle says this ordered pair is on the graph. -3, -4 is not on the graph for the green piece, but it is on the graph for the brown piece. Any questions on our logic there? If you have an open and a closed circle appearing at the same point, you use a closed circle. Now let's pick the graph, A, B, C, or D.
Okay, let me move this up. And let's see.
A,
No.
clearly not A. B, no, clearly not B. C is looking good. I think it's C. Look at this point of intersection where the two pieces meet. Right here, right there.
Yeah.
Is it a closed dot?
Yeah.
Okay.
And it's at -3, 4.
I bet you part D
It's not it.
not.
Yeah. Okay.
So
So
spots.
y'all agree with C?
Yep.
And any questions there? Quadratic functions.
That's the piecewise part.
There's two topics in this assignment. The piecewise functions and the quadratic functions. We graphed quadratic functions during that first assignment dealing with graphing when they introduced the graphing tools to us. And I said in a few weeks we're going to look at quadratic functions in more detail. Well, it's now time. So quadratic functions.
Y'all remember the word quadratic. It's got to have an x square.
Quadratic functions. It's a function that's in the form y equals or f of x equals. Remember, f of x and y are the same thing. Ax squared plus bx plus c. A quadratic equation has to have that ax squared plus bx plus c equaling 0. A quadratic function has to have the function equaling the quadratic expression. And when we were defining quadratic equations several weeks ago, we made the remark that that a value can't be 0. If a is 0, 0 times x squared, 0 times x squared, do we even have an x squared term if a were 0? No. So you've got to have that x squared term. We said that that graph was a smooth U shape called a parabola. And the parabola can open either upward or it can open downward.
I wonder why it can't open left and right when you're talking about quadratic functions.
I think they can figure this out. Let's suppose it's opening left and right.
Is that a function?
We're only going to graph the parabolas that are functions. If the U is laying on the side, is it a function? No, it fails the vertical line test, not a function. Here's something I remember from my algebra class in high school 40-something years ago. We would graph the parabolas that were laying on the side also, and the rule was the parabola opens around the unsquared variable. For a parabola, a quadratic function, the x squared is being squared. The thing that's not being squared is y. So y-axis runs up and down. So something like this would be in the form x equals ay squared plus by. Don't bother writing this down. But in order for the parabola to open left-right, it would have to be solved for x, and the y variable would be squared. But as I said, parabolas of that aren't functions generally are not of no interest to us. When you look at the equation, you can draw some, get some information just by looking at the function they give you. If the leading coefficient is positive, if a is positive, you expect the parabola to open upward. If a is negative, you expect the parabola to open downward. The point at which the graph changes directions is called the vertex. There and there. The vertex, of course, if the parabola is opening upward, then the vertex is the lowest point on the graph. That's the lowest point on the graph. That means that's the minimum y value. The vertex is a minimum y value. I'll say minimum y value. Whereas if the parabola is opening downward, do you agree that the vertex has to be the highest point on the graph? That means this point has the biggest y value possible.
What inward is he about to say?
A maximum y value, good. There are two ways of determining the location of the vertex of a parabola. One of them is completing the square, and that's just never the quickest thing to do. The other one is the vertex formula, which is also the axis formula. I'll discuss what the axis is in a moment. But we have the vertex or axis formula. X equals...
Hey, do y'all remember the quadratic formula? How does it start off?
There's a fraction. What's the first thing you have on top of the quadratic formula? X equals negative b
plus minus square root b squared minus 4ac all over.
What's the denominator of the quadratic formula?
2a.
This vertex formula is just the quadratic formula without the plus, minus, square root, all that messy stuff. Just negative b over 2a. If parabolas are symmetric about a vertical line passing through the axis, if I tried to take this parabola and fold it down the imaginary vertical line passing through the vertex. That imaginary vertical line that passes through the vertex is called the axis. If I were to fold this paper down across that, down that line right there, the right-hand portion should lie directly on top of the left-hand portion. These things are symmetric about that axis. Likewise, if I drew my axis there, and I folded the paper over.
And if your graph were really precise.
And the right, yeah. Yeah, we have human error here. But if it were real precise, the right-hand portion of the graph would lie directly on the left-hand portion. And let's see, I feel like there's more stuff I need to say about these things. What about the domain and the range? You're right. Let's talk about domain and range.
A week ago, Tim gave you a rule about domains of functions. If there's no square roots and no fractions, what do you say the domain is? Trying to figure out what numbers can you plug in.
The domain of a quadratic function is always... I remember telling y'all, if your function has no fractions, no square roots, I think I even wrote it down. Yeah, let's look back. I think I wrote it down somewhere. Well, maybe not. Let's see. Okay. There it is. If your function, and this is a quadratic function, this number 15 I'm looking at from the last time, It had no square root, no fractions. What do we say the domain is?
Negative infinity.
All real numbers, negative infinity to positive infinity. So quadratic functions aren't going to have square roots or fractions with variables under them. So it doesn't matter what the quadratic function is. The domain is always negative infinity to positive infinity.
There's going to be some problems where it asks you, what's the domain of this quadratic function?
Now, the range for quadratic functions takes a little more explanation. The range quadratic function. We'll look at two different possibilities. Okay.
Oh, I was just going to look at this. Okay.
Okay, there. Let's suppose this is the point, this thing right here. We found the vertex. We used our vertex formula. We found that the vertex is located at 3, 4. What is the range? We said if the parabola is opening upward, at the vertex, you're going to have a minimum y value. What's the smallest y value on this graph? 4 is the smallest y value on this graph, okay? And 4 is being used. So that's the smallest y value. What's the biggest y value on the graph? Is there one?
Or does it just keep going up?
It keeps going up, and so 4 to infinity. If you're looking at a parabola that's opening upward, then the y-coordinate of the vertex will be the minimum y value, and then every other number bigger than 4 will be used as a y-coordinate. Y'all follow our logic there. You follow my logic there. The y-coordinate of the vertex is the smallest y-coordinate when a parabola is opening upward, and then it just never stops. It just keeps going and going forever. So bracket 4 to infinity. And we're using a bracket because 4 is actually being used as the y-coordinate. So in general, for a parabola opening upward, let's see if I can write this. In general, it's the y-coordinate of the vertex, comma, infinity.
If it's opening up.
If it's opening upward. The y-coordinate is a minimum. That's the y-coordinate of the vertex is the minimum y-coordinate. So you expect the range to be in this format here. Let's apply that same logic to a parabola that's opening downward. Let's suppose that this is the point. There's the vertex. We've used our vertex formula and we found that the vertex is once again the ordered pair 3, 4. This is the highest number. This is the highest point on the graph. That means what's the biggest y-coordinate on this graph?
4.
Okay. But remember, with interval notation, it has to go small to big. So we know the biggest y-coordinate is going to be a 4. Notice how it's going down. All those negative y values are going to be used. So the smallest y-coordinate on the graph, we'd say negative infinity, up to positive 4. They're going to be asking for the range when you're drawing these graphs. Any questions on my logic? In general, for the range, when a parabola is opening downward, the range will be in the form, I'll say, in general, the range equals, it'll be parenthesis negative infinity, comma, this number will be the y-coordinate of the graph,
Of the vertex.
vertex. And this number's being used. It's being used as the y-coordinate. So to indicate it's being used, we have a bracket. That's a lot of information there regarding parabolas.
Today they feel like they're taking 2 math classes at once. Okay, let's do number 9. I think that's a really...
Okay, I'm going to let Tony take over with the talking now.
Okay.
So tense. I don't know if y'all can tell, but I'm
Why are
writing,
you so
sitting up there
tense?
writing, I'm so tense.
Oh, wow.
I'm pressing
Okay.
down hard.
So look at this problem. It says graph the quadratic function, and then we got to give the vertex, axis, domain, range. But let's see. The way we're going to graph these, we're going to find the vertex and one other point. I'd write that out. I'd write that out as a guideline for graphing. Let's see. To graph a parabola, first find the vertex. That means do the minus b over 2a formula and then plug it in to get the y value. First find the vertex. And once you know that vertex, find one other point. That's all it's going to need for the graphing tool. Then find one other point. In other words, plug in any other number other than whatever minus b over 2a. And find one other point. Now there's a very nice graphing tool, so you need to make sure that the ordered pairs you're finding can be labeled on the little grid they give you. So my advice to you, once you find the location of the vertex, choose your other x value within 2 units of the vertex. You'll see what he means in a moment. And there's no rule. It's just if it's going to fit on the graph. You don't want to wind up with a y value of 100 when there's no 100 on your graph. So let me write down number 9. F of x equals negative 3x squared. Already, I know how this thing is going to be opening, up or down. I'll discuss that in a moment. I can picture this graph in my head, the general shape. Is this function, and we'll need to know the vertex, axis, domain, and range. I'll remember that. Vertex, axis, domain, range. One of these, draw a blank for each one of them. I just assume the line is there. That's it. No. One of these we can fill in one of those blanks right now. Every every quadratic function has the same one of those. Which one can we fill in? The vertex, axis, domain, and range. Which one? One, it doesn't matter what the numbers are. If it's a quadratic function, I think we know something about the domain. Quadratic function. The domain of a quadratic function is always negative infinity, comma infinity. So that one we can write in right now. Negative infinity, comma infinity. We'll just wait and type it in later. Let's determine the vertex. Use the little vertex formula first of all. That's the minus b over 2a. Minus b over 2 times a. Now, what's b? Looking at number 9. What's the b value? They're just not speaking. Negative 24. So the minus b, negative 24. Is that just going to be a positive 24 on top? Let's say bottom 2 times a. What's that a? Negative 3. Are we getting 24 to positive 24 divided by negative 6? Is that, y'all agree with this? Y'all caught up with me? Y'all are mighty quiet. A negative 4. So is the vertex negative 4? Well, no, the vertex is an ordered pair. You've got to have parentheses and an x and y.
Now,
we get
x equals negative 4, that's the axis. The axis is an imaginary vertical line, and when we were graphing lines, we said vertical lines always have an equation in the form x equals a number. So when you're typing in that axis, realize they're going to be looking for a vertical line, the equation of a vertical line, which is x equals, in this case, negative 4.
You see, that's why this is called the vertex formula or the axis formula. It gets you the x-coordinate of the vertex, and at the same time, it actually gets you the equation of the axis. X equals negative 4.
I make a little table of values now. Plug in negative 4.
Okay. X, Y. First thing there is that vertex. Well, that thing right there. You got to plug in negative 4. If you can pull up your calculator, where is it? But you do it like that to show them. Make sure when you're plugging in a negative number, you make sure you're putting it in parentheses when you're squaring it. Negative 3
times negative 4 squared.
Negative 4 times negative 4 is 16. 16 times negative 3 is negative 48. Oh, 24 times a negative 4, 96. So plus 96. Oh, 3. And then minus 45.
This graphing tool is similar to that graphing tool that we had for absolute values. You found the vertex, you plot one other point, and it does all the symmetry for you. Well, what's my favorite number to plug in? If I'm choosing a number, what do I like to plug in? I'll plug in a 0. 0 minus 0 minus 45. I'm getting a negative 45. Do you think that they'll let me count down 45 units on the grid they give me? Mm-mm. So while I could plug in a 0 and get the ordered pair 0, negative 45, that's no good because I'm not going to be able to plot it. You need to choose an x value that's within 2 units of your vertex value. So you could use a negative 2 or a negative 3 or a negative 5 or negative 6. If you use anything further than that, you'll probably get a point that's off the grid. So use an x value close to negative 4.
I say just use 1 unit over. So negative 4, either use a negative 3 or a negative 5. Which other point do you want us to use? Choose a number.
Negative 5, good, because we already have a 3 there, so why use a negative 3? Plug in the negative 5. We have negative 3 times negative 5 squared minus 24 times negative 5 minus 45. Oh, look at that. I'm getting 0.
So we're going to graph this parabola using these 2 points. Let's go ahead and start typing in. What do they want us to type in first?
I think the first thing they want us to do is draw the graph.
Oh,
and
okay.
then answer, fill in all the blanks.
Oh, okay, well, let's get going.
Let's make sure they got it. I got this written down. The first thing they want us, they want us to type the vertex. Okay. So the vertex was, what was it, negative 4, comma 3?
Sure you put those parentheses around there.
Now they want us to draw the graph. I'll click
to enlarge the grid. I know. And okay.
You know what, Tim? Maybe let's look at this graph over here.
The problem is the way you have to blow up everything for the print thing. And so then you don't see the instructions. I think it's okay. We know if we can't see the little grid that we'll just be looking up here to see what the coordinates are. First thing you have to do is choose the quadratic tool. We used a 3-point quadratic tool back when we first saw these graphing tools, but now we have a 2-point quadratic tool. And I think right here is that a vertical parabola tool. You say, well, that parabola is opening upward, and the one we just drew, did they ever even answer how it was going to open?
How is it going to open? The first number is negative, so are we expecting it to open up or down? If A is positive, oh, Tim, they can't see what I'm pointing at. If A is positive, it opens up. If A is negative, it opens down. Our A value is -3, so we know it's going to open down. Something like that. Okay?
But you still use the vertical parabola tool. It's opening up or down. That's the one you click. I'll tell you right now, you're not going to be using the horizontal parabola tool because those things are not functions, and we said we're only graphing parabolas that are functions. So now the first point you have to plot is the vertex. 4, -3. Let's see. Or is it 4, +3?
It's -4.
-4, +3. There's the vertex. Do y'all see where I'm looking in that yellow box? Seeing -4, +3? I click it, and now as I move my mouse around, you'll notice it's drawing every possible parabola that has a vertex at -4, +3. Well, what was our secondary point? We plotted,
-5, 0.
We plotted -4, 3. Now we need to plot -5, 0. Okay, -5, 0. Is that it? Yeah, that's it.
Now it looks better over there.
And check.
And we're not finished.
Now they want the axis. Remember, the axis is an equation. X equals, what was that x coordinate of the vertex?
-4.
-4.
That axis, you always write when it asks for the axis. You type in X equals, and then whatever the...
I think on number 8 they give you the x equals already.
Okay.
But the domain, well, we know the domain. All quadratic functions have the same domain, -infinity, comma, +infinity, enclosed in parentheses. The range. Remember we said the range
takes
some discussion. Look back at how we have it here.
Okay. But, okay. What we were doing here, if a parabola opens upward, then the range is in the form y-coordinate of the vertex, comma, infinity. The one we're doing, the parabola is opening downward. So let them look at that graph and analyze it.
There it is.
What's the biggest y value on that graph? It's the biggest y value. It's there at the vertex. What's the y value of that vertex? That's the x value. What's the y coordinate? 3?
3. 3 is the highest, that's the highest point on the graph. Are there any other bigger y coordinates than 3 on this graph? No. So 3 is the biggest one, and then every y value smaller than that is used.
Okay, show my paper. So what he just said, the biggest y value is 3, so that means it's on the right. And then everything smaller, negative infinity. The range, since it's opening down, is in the form negative infinity, comma, the y-coordinate of the vertex.
Is 10 used as, is 10 in the range? Could you plug in a number to give you a y value of 10? Is 10 in the range?
No.
What's the biggest number that's in the range?
3.
3.
3, 2, 1, 0, negative 1, negative 2, negative 3.
Any questions on our logic?
See how we got that range?
Oh, and notice the generalization that I wrote. If the parabola is opening downward, the range is parentheses, negative infinity, comma, the y-coordinate of the vertex. The y-coordinate of the vertex was 3. And then brackets. I don't think we're finished. I think we have to type in the range, right?
Yeah.
Here it is. Here's the range.
Give them something to look forward to.
Parentheses, negative infinity, comma, 3, bracket.
Okay. Now, I wanted to get all 3 of those word problems done. Start that, or do
Okay.
another one of these?
Maybe we should do another one. They're so quiet.
Okay.
Okay, we're going to go back to number 8.
I think 9 is probably the messiest one.
Yeah.
Number 8, same type of problem. Graph the quadratic function f of x equals x squared plus 12x
Plus 32.
plus 32.
Same instructions. Vertex,
Vertex.
axis, domain, and range.
Axis. Which one can I fill in right now?
Domain.
Domain. Good. Hey, is this going to open up or down?
What's my A value? What's the leading coefficient?
I'm going to write a number right here. It would be a 1, right? A is 1.
So A is positive. Do you expect the parabola to open upward or downward? Up. A is positive. So when we draw the graph, we expect it to look like that.
Let's find that vertex and axis. Starting off with the little formula, minus b over 2a. We have a minus.
What's B? 12, I agree. A, 1.
2 times 1, I'll do that in my head, just 2. So the x-coordinate of the vertex is negative 6.
We can fill in one of those lines up here.
And we can fill in half of this
We can
one.
fill in half of that. What other line can we fill in? The axis is x equals negative 6.
Tempting just to write negative 6, but make sure it's an equation. My brother said he thinks that on this one they already have the x equals typed in.
And I'd now make a table of values.
X.
The first number I would plug in is the number for the vertex.
Negative 6.
Now we'll need another number to plug in. It doesn't matter what, I'd prefer to use 0. 0 plus 0 plus 32. You think they'll let me count up 32 units when they give me that graph? I don't think so. So choose something close to negative 6 to plug in. What do you want to plug in as the secondary x value? Negative 7? Okay. Now let's plug them in. Oh, here it is. It's already here. Let me clean off all that. So we have a negative 6 squared plus 12 times negative 6 plus 32 a negative 4. So we can fill in that number there for the vertex. The y coordinate is negative 4. Now let's plug in that number negative 7. Oh, by the way, if your calculator doesn't have one of those little those little exponent keys, then probably it has a caret top key. Negative 7, notice the little caret top, and then you got to put in the square. So plus 12 times negative 7, negative 84, and 82. This is working out pretty nicely. Negative 3.
Negative 3. Okay.
49 minus 84 plus 32 gives me a negative 3.
Now, when we talk, since it's opening upward,
I think we can
talk about the range. Are we expecting it to be going up to positive infinity, or the y value is going to be going down to negative infinity if it's open up?
Positive.
Yeah, so we can go ahead and write it out. The lowest y value is negative 4 up to positive infinity. And what's actually at the graph?
Label that point. Negative 6, negative 4.
This point right here is the vertex.
And that y coordinate of negative 4 is the lowest point on the graph. So look back at that generalization I made regarding parabolas opening upward with regards to the range. It's 2 pages back.
Opening up.
Mm-hmm.
Opening up. Oh, the range is in the form y coordinate of the vertex, comma infinity. Let's see what we have over here. Y coordinate of the vertex, positive infinity. Years ago, I remember a student I had, Laura, asked in class, is it true to say that when you're looking at the vertex, this x value will always be in the axis and the y value will always be in the range? And I said, yes, that is true.
Oh, that's a good
X value will
observation.
always be in the axis, the y value will always be in the range, and we called that Laura's rule because Laura was the one that stated it. Now all we got to do is graph it. Well, I guess you got to type it.
Type in all the answers
Uh-huh.
also. Oh, there. Okay, hold on there. So the vertex was negative 6, negative 4, put in parentheses.
The axis is x equals negative 6.
Oh,
wait,
no,
no,
they
we
want
got
me
to
There. We click the vertical parabola tool, and then they want us to plot the vertex. That was negative 6, negative 4, negative 6. Oh, goodness. Is that it?
Negative 6, negative 4, yes.
And then, as we move our mouse around, we see every possible parabola with a vertex at negative 6, negative 4. We need one additional point. What do we have? Negative 7?
Negative 3.
Oh.
Pretty darn close to that. Oh, negative 7, negative 3.
There. Transfer it back over to the original
Okay.
grid. Looks a lot better there, doesn't it?
And you'll notice, look at the range. All the y values. The smallest one is negative 4, and then they just go up.
Mm-hmm. So let's check that graph. And the axis. No, they didn't give us the x equals. I thought they gave us x equals, but they didn't. So you have to type x equals negative 6. And here,
Domain Always
negative infinity, comma infinity, and the range. We said that the smallest y coordinate was -4. It occurred at the vertex, and then every number bigger than -4 would be used as a y coordinate. Every number bigger than -4 would be used twice. We all agree? Something like 8. Every number bigger than -4 will be used twice as y values.
Only twice.
Only twice, right? Exactly twice.
I'll give you a good. I remember what's happened to teacher, and we had these little true-false questions.
Is this something you're telling me, or you're telling
I'm telling the class.
Oh, I thought you were just telling me something. I was about to say, this is not the time, Tony. They're getting anxious. They've been here going almost 2 hours, and we haven't even started the word problem.
I was going to start the word problem, but you wanted to redo number 8, or do number 8, which I don't really think added much.
I'll tell you right now, with quadratic functions, either a maximum or a minimum will occur where? At the vertex. These word problems, they're going to be asking you to determine either a maximum or the minimum value, one or the other. Well, every time for a quadratic function, those maximum or minimum occurs at the vertex. So my advice to you, use the vertex formula. X equals minus b over 2a.
Show them what I'm writing down.
Okay.
For the word problems, I think they start with number 11. 11, 12, 13. You're going to do this. It's the easiest word problems you can have because they follow a pattern. Find minus b over 2a and then plug it in, you'll get the answer. Hopefully you'll understand the problem, but even if you didn't.
Let's do number 11.
Yes, we're going to do number. Okay.
A woman has a. Oh, you have the map.
A woman has a taco stand. She's found that her daily costs are approximated by. Here's the quadratic function. It has to have an x squared in order for it to be a quadratic function. C of x equals x squared minus 40x plus 640, where C of x is the cost in dollars to sell X units of tacos.
Write that down. C of x cost
is the number of units of tacos.
Okay.
We don't know how big a unit is. Maybe it's an order of 3. Maybe it's just one taco. And C of x is the cost.
Y'all should be happy to notice that Tony's starting the problem down real low on the page. That means it's not going to take a lot of work. If it were going to take a lot of work, you would have started number 11 on a new sheet of paper. And notice what they're asking for. They're asking us,
you didn't finish reading.
Find the number of units of tacos she should sell to minimize her costs. And what is that minimum cost? Well, they didn't ask us to draw a graph of this function, but if they did, would we expect it to open up or down?
Show us paper.
What's the a value there?
+1.
So it's going to be opening up. The a value is positive, so we expect it to open upward. Now,
what's that vertex going to be, a maximum or a minimum?
If the parabola is opening upward, does the vertex correspond to the maximum y value or the minimum y value? That's the minimum. That's the smallest y value. Is that what they're asking for? Were they asking for the smallest y value? Let's go back over here. Sure enough, they're asking for the minimum. There's not a maximum. Okay, that maximum, the range keeps going up and up. They want to know her minimum cost, and that's located at the vertex.
So show my paper. I'm going to find that x coordinate of the vertex, and so I'll be finding the number of units of tacos, minus B. B is a negative 40, so we have negative, negative, so that's a positive 40.
And what's A?
Number 2
1, so
times
2 times 1 is 2.
40 divided by 2.
Is that saying her minimum cost of $20? What is X representing?
Number of tacos.
So that X is the number of tacos, the number of units of tacos. So I don't know what a unit is, probably a dozen, so 20 dozen. But the important thing is that X value is not dollars, it's a number of units of tacos. So if she wants to minimize her cost, she needs to try to sell 20 units of tacos each day.
And how do we find that cost? Once you find the minus B over 2A, what did I say to do?
Once you know the X value, how do you find the Y value?
Plug it in. So you're going to use your calculator for that to find C of 20.
It'd be 400 minus 800, which is negative 400, plus 640. I'm getting 240. Let's see if this calculator is going to agree with me. Okay, or there it is. Let's see. Clear off all of that. We have 20 squared minus 40 times 20 plus 640. Yep, 240. Now, is that $240? Or is that 240 tacos?
C of X is the cost, so that's dollars. So she needs to sell 20 units of tacos, and it'll cost her $240 to do that. That's going to be her minimum cost.
That
Like if
means
she sold no tacos, how much money, or what did it cost her that day? If you plug a 0 in for X, $640. If she didn't sell any tacos, she's going to be
out $640. If she sells 20 tacos, units of tacos, her total cost would be $240.
Let's go ahead and
type in the answer.
20.
So the number of units of tacos she should sell is 20. And in that event, the cost is $240. Any questions there?
Minus B over 2A and then plug it in.
So realize for a quadratic function, you either have a maximum or a minimum. You can't have both on the same problem. If it's opening upward, you can find the minimum. Let's see what's the next one.
Now, this one's tricky. The number of mosquitoes in millions in a certain area depends on the June rainfall, X in inches. So X is the number of inches of rain. The function that models that phenomenon is M of X, probably M for mosquitoes. And here's why it's tricky. 8x minus x squared.
They give you the function. And hopefully you'll agree it's a quadratic function. It has that x squared. But what do we dislike about that function?
Is it in standard form?
What's a? I'd rewrite it. Write it in descending order. Put the x square term and then the x term. Because we're going to need to know the A and B values.
See, A is -1, B is 8. Okay?
A is the coefficient of x squared. It doesn't matter if it wasn't written first. B is the coefficient just of x.
Hey, so is this thing opening up or down? Looking nice.
If you were to draw this parabola, it's opening down because A is negative. If it's opening down, what do you have, a maximum or a minimum? maximum y value or minimum y value? I heard a maximum and I agree because it's the highest point up there. Is that what they're looking for?
They better be asking about a maximum or else we can't answer the question.
Find the
Yeah.
amount of rainfall that will maximize the number of mosquitoes. And what is the maximum number of mosquitoes? Yes, they're asking for a maximum. So we use our little vertex formula.
Minus b over 2a. And b is that 8. So minus 8 over, what do we have in the bottom? 2 times a, 2 times negative 1 is negative 2. For these word problems, you should not expect negative answers. If x is the number of inches of rain,
Or the number of tacos she's making.
you can't have negatives on those. So what we just found is with 4 inches, we're going to have the maximum number of mosquitoes.
X is the number of inches. That's not saying we're going to have 4 million mosquitoes. It's saying that 4 inches of rain will maximize the number of mosquitoes in that area. To determine how many mosquitoes you have, that's when you plug in the 4. So let's see. So that's a negative 1 times 4 squared plus 8 times 4.
This one I can do in my hand. Negative 16 plus 32. That's going to be a 16. So are there 16 mosquitoes? I think it's
16 million mosquitoes. This is the number in, I better put in the number of inches first. We said that was going to be 4. And, they've written out the million for you. So what's the number they want you to type in there? The 16.
So there's 16 million mosquitoes when there's 4 inches of rain.
I don't know if I always thought the more rain, the more mosquitoes during the wet. There is a point at which they start drowning.
Yeah, well,
Do mosquitoes drown?
I don't know, but I think that there's some point at which there's too much water. Okay? Let's just suppose that it rained and flooded the world. Okay? Mosquitoes don't grow in salt water.
And there wouldn't be any humans for them to eat, to set the blood on, and so you're right.
There's some, okay. One more.
Oh, is this the last one?
Oh, yeah. Okay, if an object is projected upward from ground level with an initial velocity of 96 feet per second. Hey, so show my paper for a moment. We're throwing some object upward. Is this parabola going to be opening up or down?
Now, so when you throw that object upward, what's going to happen?
And it goes
Back down.
So it better be asking us what sort of question? A maximum or minimum problem?
It better be a maximized problem. Let's finish reading it and see. Okay. So they're using a different variable. T is taking the place of x.
And it says t seconds.
And then the height, s of t, is equal to negative 16t squared plus 96t.
Oh, okay, good. It's in standard form.
Find the number of seconds it will take to reach its maximum. That's exactly what we expected. We expected it to be asking for a maximum because this thing here is opening downward.
I guess if it asks what's the minimum, well, 0 feet. If you're throwing it from ground level.
Yeah, you're right.
Whatever the person.
Did he write down the function?
Yes.
Okay.
So now minus b over 2a.
Remember, it's t equals not minus b over 2a, not x equals for this problem.
I think it was a x equals it won't hurt.
Yeah, you're right.
Minus b over 2 times a. 2 times negative 16 is a negative 32. Since t is seconds, it better not be negative. Am I getting a negative answer here? No. Let's see, what's negative divided by negative? That's positive. 96 divided by 32, is that a 3? So they threw the ball, rock, whatever, up in the air. It goes up for 3 seconds, then it comes
back
down. So this is how many seconds it takes for it to reach the height. 3 seconds.
How do we find the height? Once you find the first coordinate of the vertex, what do? Plug it in to get the second coordinate.
S of 3.
Negative 16 times 3.
I wrote it out, but
plus.
I think most people are probably using a calculator to get those. 144. Okay, that's a pretty good throw, if it was a throw. So threw the thing up.
Functions of this form are called position functions.
Any
That
future
negative
physicists
16t
out there?
squared is a result of acceleration due to gravity, okay? And there's the initial, if there was no
Rate
gravity
times time.
pulling it down, it'd just be rate times time.
It's
96 feet per second times the number of seconds. But this negative 16t squared is the effect of gravity trying to pull the object back down to Earth.
And they just really want you to enter 3 and 144 to get it over with.
I don't believe that. I want you to ramble on a little bit. And so it took the object 3 seconds to reach its maximum height. And how high was it? 144 feet.
Then once you get to number 14, it's some of those problems. There's 2 problems dealing with reviewing how to find
Domain.
where you can't have a
Can't let the denominator. I
zero.
remember this problem. From last time.
Okay. So any questions on this? So quadratic functions minus b over 2a gets you that parabola.
The vertex.
I mean the
of
vertex
parabola.
of the parabola. Oh, did you stop? Oh no, yeah, stop recording. But on Wednesday, what are we doing on Wednesday? Oh, any questions?
Okay, I'm going to stop recording.